Good day, everyone. Thanks for joining today's class. Today, we're carrying out calculation of impedance represented with capital letter Z and also current represented with capital letter I, voltage represented with capital letter V, and power represented with letter P in the circuit. You can see what's given to us in the question. We have to look for the impedance, current, voltage, and average power used in the circuit diagram below. Impedance is the overall opposition to the flow of alternating currents in the RC circuits. This is your R, the resistance, and this is your capacitor. Okay, that's RC circuit. We have some cases where you have RLC circuit. In that case, we involve the inductor. The symbol for inductor. We don't have it in the circuit diagram. And what we need to know about the formula for impedance: Z equals square root of R squared plus XC squared. You can see the capacitor. It has two long hands of the same length. That's capacitor. If it is a cell, you have a long hand, a short hand, is cell. If it's battery, combination of cell to give us battery. Okay, please let's take notes. Now we are giving the value for capacitor. That's 5 microfarad. Convert it to farad by saying 5 times 10 raised power minus 6 farad. The resistor value R equals 300 ohms. Always take note that the unit of the impedance is also ohms. Okay? The unit of impedance is ohms. Unit of resistor is also ohms. Unit of capacitive reactance is also ohms. Okay, we call this capacitive reactance XC because it's called capacitive reactance. Called capacitive reactance. This X stands as the reactance, C is the capacitive reactance. Call it capacitive reactance. Is that okay? This is we use C to represent capacitor, but when you join it with reactance, which is X, we call it capacitive reactance. If it is XL, inductive reactance. Okay? And they are also in ohms. You see? Or you have some cases in which it might involve XC and XL. Okay? Now, we are going to see some problem that we are going to solve when it involves capacitor and inductor in the circuit. Now, let's go to our question. We have to look for the impedance. You can see impedance is square root of R squared plus XC squared. You can see that we don't have XC, capacitive reactance. The formula is 1 over 2 pi FC. Now, don't forget that we have some values given to us in which we must write down. Your V equals 200 volts. This is your frequency. Your frequency is 250 over pi hertz. You are not given pi. That means that you carry out your calculation in terms of pi. Or if you are given the value for pi, you substitute in the question as you are solving it. Like now, you are having pi here. If you are giving pi to be 22 over 7, just substitute your pi there, but since you are not giving the value for pi, we are going to work it in terms of pi. Okay, and let's go to the capacitive reactance formula, 1 over 2 pi Fc. If it is inductive reactance will just be 2 pi Fl. Okay, but we are not solving a problem involving inductor. And let's go back to our question. Xc now equals 1 over 2 pi Fc, which is equals to 1 over 2 pi times what's our frequency? 250 over pi. What is the capacitor? Capacitor is 5 times 10 to the power minus 6. Let me repeat it here so that you can occupy the space. Xc now equals 1 over 2 pi Fc, which is equals to 1 over 2 times pi times frequency. And see, these are frequency, unit of frequency is hertz. You can see the comma separating the PD from the frequency. The voltage is this separated from the frequency with this comma. Okay, that's 250 over pi. What's the capacitor? 5 microfarad, and you have expressed it as 5 times 10 to the power minus 6 and 5 times 10 to the power minus 6. That's over 1. Pi cancel pi. Okay, now since you have it like this, you know 2 times 250, you have your Xc to be 1 over 500 times 5 times 10 to the power minus 6. When you get that, multiply 500 times 5, your X equals 1 over 2500 times 10 to the power minus 6. And let's change this one to standard form so that we can combine it with 10 to the power minus 6, which is 1 over, shift like this, 1, 2, 2 place, shift 2 times. So 25 times 10 to the power 2. We are shifting from right to left. It will be positive index times 10 to the power minus 4. Sorry, minus 6. Times 10 to the power minus 6. Okay? Times 10 to the power minus 6. Now Xc, which is capacitive reactance, 1 over 25 times 10 to the power 2 plus minus 6. Okay, you now have it to be 1 over 25 times 10 to the power 2 plus minus 6, that's minus 4. That's minus 4. Now, let's now write like Xc now equals 1 over 25. Let's separate it times 1 over 10 to the power minus 4. Okay? Now, in indices, when this 10 to the power minus 4 want to go up, it's turned to positive because of this division is negative. Okay, minus 4, it turned to positive. Okay, because in indices we also do like this: a raised to the power minus 1 equals 1 over a. Okay, now if that should be the case, you're having 10 to the power minus 4. It's not this will be 1 over 10 to the power minus 4, give us 1 over, we have 1 here. This one now, let's turn it to, let's follow the indices. 1 over 10 to the power 4. Don't forget this one, they are together, which is 1 over 1 divided by 1 over 10 to the power 4, which is 1 over 1 times 10 to the power 4 over 1. See how this how it goes up. Okay, from negative turn to positive. Now, which is 10 to the power 4 times 1, that's 10 to the power 4 divided by 1 will give us 10 to the power 4. Okay, this 10 to the power minus 4, when it goes up, turn to 10 to the power 4. Now have it to be 1 divided by 25 times 10 to the power 4. In this case, you will not put 1 there again. Now let's divide it. Let's put 1. 1 divided by 25. 25 goes in 1, impossible, 0 point, add the 0. 25 goes in 10, impossible, 0, add a 0. 25 goes in 100 as 4. That's 0.04. 0.04. Your capacitive reactance equals 0.04 times 10 is power 4. Okay, now when you are shifting from left to right, it will be negative. Now shifting 1, 2, it will now be equal to 4 times 10 is power minus 2 times 10 is power 4. Now it will be xc equals 4 times 10 is power minus 2 plus, in indices multiplication will change to positive at the power. We are using 110 to represent the 2. 10 is power minus 2 plus 4 becomes 4 times 10 is power minus 2 plus 4, that's 2. Okay, which is equal to 400 ohms. Let's see now, capacitive reactance is 400 ohms. Okay, now go back to solving. You have gotten our capacitive reactance. We want to substitute into the value, substitute the value into the formula. Okay, and substitute the value into the formula. Now, from here, you now have your impedance, which is overall opposition to the flow of alternating current. You now have this symbol to show that is an alternating current. Okay, now Z equals to square root of what's our resistance? 300 square. We're going to square because of this square plus 400 squared. Now Z equals 300 squared as 90,000. 90,000 plus 400 squared, that's, that's times 4. 160,000 plus 160,000. When you add it together, you're having 160 plus 90. That's 250,000. That's Z equals square root of 250,000. Okay. Now we want to get the square root of 250,000. The impedance equals square root of 25 is 5. And we have 4 is 0, you pick 1, which is 500 ohms. Your impedance is 500 ohm. When you're having 4 is 0, you pick 2 is 0 as the square root of um, 4 is 0. What I'm trying to say is that in this case, you can show it in indices and just say equals to square root of 25 times 10 is power, how many zeros? 10 is power 4, I've seen it, okay, which is equals to, let me show you how we go to 500. Just your impedance equals square root of 25 is 5 times this 10 raised by 4 will be 10 raised by 4 times half, which is the square root, 2 here 1, 2 here 2, which is equal to 5 times 10 raised by 2. Impedance now equals 500 ohms, because 10 squared is 100, and 100 times 5 gives us 500 ohms. That's the overall position to the flow of alternating currents. Now let's go to the second question, which is the current in the circuit. Don't forget that V equals to IZ. V equals IZ, current in the circuit. And I have make I the subject of the formula. This got from Ohm's law. From Ohm's law. Ohm's law. From Ohm's law, you know that we have V equals to IR. But since we are dealing with overall proportion to the flow of current, you change your resistance to the impedance. Now, making I the subject of the formula equals to V divided by Z, divide both sides by Z, you have I equals to V over Z. What's our voltage? 200. 200 divided by impedance, 500. 0, 0, 0, 0. Left with current to 2 over 5. Let's divide it. Put 2 here and 5 here outside. 5 into impossible 0 point. 5 in add the 0. You say 5 into 2 0 point add the 0. 5 in 24 times 4 20. That's 0.40. The currents flowing in the circuit equal 0.40 ampere. I've gotten that. This is the first one. The second one, to get the second one is this. The third one, average, no, the voltage. The voltage, the circuit, V equals to I Z. Okay, what is your current? Your current is 0.4. What is the impedance? 500. Okay, now in our V to be 4 over 10. Decimal standard as 1. How many number after decimal? 4. How many figure after decimal is 1, which is 4. Is that okay? You know, right? You will not put 4 down. You look at the number that the numbers of occurrence of numbers. Is that okay? The number of times the number occurs after decimal. You can see here you having one number after decimal. That's why I take it as 1 is zeros times 500. 0 comes to 0. 5 times uh, 50, 4 times 50, that's 200 volts. That voltage, average power used in the circuit. Power equals to IV, which is equals to I times IR equals to I squared R. Okay, and the power now equals, what is the current? 0.4 square times resistor, resistance value, which is 300. Now, when you multiply that, you have 0.4 times 0.4. 4 times 4, 16, carry 1. 4 times 0 is 0.1. 0 times 4 is 0. 0 times 0 is 0. 610. I mean, count the number that occurs after decimal, before decimal. 1, 2. Now, shift 1, 2. That's 0.16 times 300. Now it will be, the power will now be equal to 16 over 100. Now see what I'm saying, that how many number after decimal? 2. 1, 2. Add 2, 0. And decimal is 1 times 300. 0 comes to 2, 0. We are left with 16 times 3, which is 48 watts. That brings us to the end of the class. Please don't forget to subscribe for more updates, and also don't forget to leave your question in the comment section. Thanks for watching. Have a wonderful day.